So in this, we're going to look at quadratic equations with imaginary roots. And so Desmos is a great tool, and I really suggest that you get familiar with it. But sometimes when we're finding roots of a quadratic, sometimes Desmos isn't real helpful. So for instance, if I pull up Desmos here, and I've already got the equation typed in, x squared minus 3x plus 10. And as you can see, at no point does this function pass the x-axis. So I have no roots. There are no real roots. And so if there are no real roots, then that must mean they're imaginary. And so that leaves us with only one method. There's only one way to find these roots, and it's by a wonderful thing called the quadratic formula. X equals minus b plus or minus the square root of b squared minus 4ac, and that's all over 2a. So we're going to have to use quadratic formula to find our roots here because they're not going to be real. They're going to have imaginary roots. All of my answers are going to have an I in them at some point. So I'm going to make myself a list. A is 1, B is -3, and C is 10. And so to find the roots using the quadratic formula, x equals minus b, so minus a -3 plus or minus the square root of b, -3 squared minus 4 times a times c, and then that's all over 2a. So all I did was plug everything in here. If you want to do the discriminant separately and then plug it in, that's fine, that works as well. Minus a negative is a positive, so x equals 3 plus or minus the square root of. And so you might grab a calculator, do some computation in your head. -3 squared will give me a positive 9. 9 minus 4 times 1 times 10. 9 minus 40. So that would give me a -31. Again, use a calculator if you need to. I just kind of did it in my head. 2 times 1 is 2. So at this point, you're probably looking at this and saying, well, there's not a whole lot I can do with this. It's not proper to leave the negative underneath the radical. So remember that the square root of -1 equals I. And so I could make this the square root of -1 times 31. And so anytime you see a negative underneath the radical, 3 plus or minus, I want to bring that negative out. And to bring that negative out, I have to have an I. Square root's of 31 over 2. There are my two roots. 3 plus I square roots of 31 over 2, and 3 minus I square roots of 31 over 2. Example 2, I could go to Desmos, look at this. I'm going to have imaginary roots. It doesn't show, so I'm going to have to quadratic formula. X equals minus b plus or minus the square root, b squared minus 4ac, and that's all over 2a. A is 1, b is 4, and c is 5. So again, I like to list things out. X equals minus b plus or minus the square root of b squared minus 4ac. And that's all over 2 times a. A is 1, so I'm not going to write it this time. 2 times 1 is just 2. Inside, again, use a calculator if you want to. 4 squared is 16. 4 times 5 is 20. 16 minus 20 would give me the square root of -4. So here when I look at this, I have a negative, so I've got to bring an I out. I've got a 4. Square root of 4 is 2. So my radical will simplify to minus 4 plus or minus 2i over 2. Now, this is like any other addition and subtraction. Anytime I have this binomial up here over a monomial, I've got to be able to factor something out I've got to be able to factor something out of both of these in order to be able to reduce. And it just so happens that this time I do. 2 will go into 4, so I can factor out a 2. That leaves me with a negative 2 plus or minus I over 2. And so those reduce. So my two roots here would be negative 2 plus or minus I. All right, example 3. Again, I would start off anytime I had a quadratic, and if I wasn't comfortable factoring, I'd throw it in Desmos. I'd look and see what Desmos showed me. You throw this into Desmos, it's going to show you that there's imaginary roots. So I'm going to have to use x equals minus b plus or minus the square root of b squared minus 4ac over 2a. A is 1. B is 8. C is 40. Big number for C there. X equals minus b plus or minus the square root of b squared minus 4 times a times c. And that's all over 2 times a. 2 times a is 1. Alright, so again, I may need to use a calculator this time. I might even take it up again. If you're at home, you don't have a calculator, then you probably have a cell phone. If you have a cell phone, then you should be able to use that. Get clearer here than what I had in there before. So I'm just going to do what's underneath the radical. 8 squared minus 4 times 1 times 40 and equal negative 96. So x equals negative 8 plus or minus the square root of negative 96 over 2. 96. 96 isn't a perfect square. I can go back to my calculator and I can get rid of that. And I can go square root of 96 gives me an irrational number. So I'm going to come over here to the side. I'm going to take 96 and I'm going to do a factor tree. Remember, when I do factor trees, I like to keep it simple. 2 times 48, 2 times 24, 2 times 12, 2 times 6, and 2 times 3. Again, if you notice that there's a perfect square, a larger perfect square, maybe a 4 or 16 or something, then go ahead and go for that. I have a pair of 2, so I have 2 to the first. I have another pair of 2, so there's 2 squared. And then I have this 2 and this 3 left over. So this 2 squared is coming out. This set of 2's is coming out, and this set of 2's. You can also look at it as 2 times 2 times 2 times 2 is 16. Square root of 16 is 4. X equals negative 8 plus or minus. We're going to take the square root of 16 plus the negative. So negative 16 would be 4i. Square root 2 times 3 is 6. An easy way to check this, again with just the calculator you got at the house, if I hit clear, I hope you can see this, I had 4 times the square root of 6. Whatever you get out of the square root, go 4 squared times 6, and it gives me 96. So you should be able to square this that you get out and multiply by what's left underneath the radical and get what you started with. Don't want to forget, it's still over 2. So once again, 8 and 4, they've got a 4 in common, and you can factor out a 4, but I noticed that I have this 2 in the denominator, and I'd really like to get rid of that 2, so I want to try to keep things a little simple. So I'm just going to factor out a 2. I know I can factor out a 4, but I'm only going to factor out a 2. 2 times negative 4 plus or minus 2I square roots of 6, and that's all over 2. Those reduce, so my final answer would be negative 4 plus or minus 2I square roots of 6. If I factored out that 4, then I might have gotten an answer like x equals 2 times negative 2 plus or minus I square roots of 6. That's an okay answer too. Both of those answers are sufficient. So we looked at finding roots of quadratic equations that have imaginary roots. X equals minus b plus or minus square root b squared minus 4ac, and it's all over 2a.